My name is Ondrej Mirtes and I'm from Prague, Czech Republic. And today I would like to show you how you can perform migrations and deployments without any downtime. So you don't have to show this icon on your website anymore. My experience mainly comes from working on a big Czech e-commerce website called Slevomat, where we have over 300,000 daily visitors. And we are deploying to production between 10 and 30 times a day without any downtimes. I will not be talking about any specific tools, but only about fundamental knowledge, so that you can make informed decisions and choose the right tool for the job. And my tips and workflows don't require any big changes to the code, so when you come back to work on Monday, you can start immediately benefiting from the things that I will tell you today. But first, I would like to start with a question. Why? Why should I care? Why should I care if my migrations and deployments are without any downtime? Sure, if you are deploying to production only once or twice every 2 weeks, your customers can definitely survive an hour or two without your website. But I would like to persuade you that you should deploy more often. So, the number one thing I recommend to companies is that they should focus more on getting quick feedback, and they should really strive for quick feedback, because the companies are really benefiting from finding out as soon as possible whether a proposed solution works or if it doesn't work, technically and also from a user's point of view. So the sooner you know that you are on the right track, the sooner you can change things in the right direction or keep going. So who heard this in their lifetime? Let's rewrite it from scratch. Okay, many people. So it happens from time to time, then someone comes up with this idea, let's rewrite it. The reasons for the rewrite might be technical debt, it might be bad decisions, or just that because some more modern technology is available and the people want to try it out. Also, it happens usually when a new team takes over a project. They don't understand the current solution, they also don't want to understand the current solution, and they want to create a new one. But the current solution needs to be respected because it works and it generates revenue, it makes money. So if you start rewriting something from scratch, then closing the gap between the old version and the new one will usually take years. And during those years, you still have to maintain the old version, because otherwise you are neglecting your users that use the old version. And the result is not certain. So even if you manage to finish the project and you complete the rewrite, it's not certain that you will end up with something better, because you are developing it on the side, and your work doing it on the side lacks feedback. So you can be sure that you are doing something right. And even if you are finished, the project might no longer be relevant to the company, to the business, because the business might have moved on and the needs of the company might have changed. So they no longer need the project as you finished it. So why am I even talking about this? Because a complete rewrite is just one possible point on a scale of different approaches. So on the one side, you have complete rewrite, and on the other side, you have your work reaching production the same day that you are writing the code. So we are all usually somewhere in the middle, which means that we are repeating the same mistakes even if we are not rewriting the software from scratch, because we are not seeking feedback and we are developing it on the side, and the development on the side can take days, it can take weeks, it can take even months. So meanwhile we are developing on the side, it means that we are neglecting version in the production, and the needs of our users are unsatisfied because we are preparing something new for them on the side for weeks and months. So even with this halfway approach, which is not entirely wrong, but certainly isn't instant, we might end up throwing our code away, or at least we will have some problems like merge conflicts, etc. So once we deliver our work, it might also be full of bugs, and we might realize that customers needed something different. Okay, so the longer we are without feedback, the worse is collision with reality, because we are getting further from real requirements. And when we do the big release at once, it means that we usually require downtime to do it, because we are deploying lots of changes at once, and we are creating some surprise for our users, and it's possible that some part of the code won't work because we weren't gathering feedback during the development. And also, because of our big release, the whole company stops because the users need to adapt, and they are busy reporting bugs to us, and we are busy fixing those bugs for them. So I would rather advocate for small releases that are much more manageable, and it's also easier to find and fix bugs in them. So the more ideal workflow looks more something like this. We deploy new versions more often, and if we do that, the software quality suddenly increases, and we are also able to fix our bugs faster. The software suddenly meets users' needs, and the users are responding to us with feedback, and we can build on their feedback many times a week. And from my experience, the most precious feedback is from production. Because if you put your users in front of some test version of your application with some test data, they might click through your application, they might note that everything is fine, but once they start using your application for real in production, they start finding real issues because the test version they didn't take very seriously. Okay. Another reason why we want to avoid downtimes is that because downtimes cost money. So if we are running some local service in a single time zone, we can find a time with a minimal impact, probably somewhere around midnight. But there is still some negative impact because someone will definitely notice that the site is down while they wanted to do something on it. And finding some possible downtime window is not possible with a global service. So I don't recommend downtimes at all because they will still get noticed. So I recommend deploying more often and without downtimes. Deploying more often shouldn't mean that we are having more downtimes. And also, downtimes are risky because when we are performing a downtime, probably at night, around midnight, we have to stay up. We have to stay up all night, and we will be sleepy, and we will make mistakes. So also doing something not very often means that the process isn't battle tested. So there's something more likely to go wrong. And as I already said, we are deploying many changes at once, which means that we are breaking use cases and workflows of our users. And we are releasing code with not enough feedback, and the code might be broken. Okay, I have a real story for you. A few years ago, we wanted to improve our downtime process, and we wanted to make sure that nothing uses the database during the downtime. So we disabled all entrances to the application, and so that means that the index.php displayed a maintenance page with an estimated time when the site will go back up. And we also modified our CLI.php that handled all the crons, so that the CLI.php immediately exits and doesn't do any harm to the modified database. But the main problem was that CLI.php also handled parts of the deploy itself. So while the site was down, we weren't able to deploy it, which was a problem. Okay, so the lesson you should take from this is that the best downtime is no downtime, which is the thing that we should have optimized for. But we instead optimized the experience of the downtime itself, but we should have avoided it. So going into maintenance mode is a little bit like going to the dark side of the moon, because no one can help you there. The communications are cut off, there's a lot of pressure put on you, and everyone is waiting for you to come back online. So this is why you should be able to deploy and maintain your application without any downtime. Okay, so now to the main topic of database migrations. So when you are working on a new feature or a change, you sometimes need to modify the underlying database schema. So the typical approach is to synchronize migration and deployment. In an ideal world, we would do exactly this. But unfortunately, this is not possible because it takes a different amount of time to do the deployment and the migration. Migration usually takes longer and is not very deterministic because the migration time can vary, but the deployment usually takes the same amount of time every time. And the thing you should do is to decouple deployment and migration. Make them independent, because the old version of the application, which is still in production, should work with the new version of the database. So you need first to do the migration and then to do the deployment, which means that the migration should always be backwards compatible. You shouldn't do any destruction to the database. It should always be backwards compatible, so you can return to the old version of the application, and you won't break the version in production. And it's important to realize that the deployments and the database and application have different life cycles, which means that the deployment usually succeeds and takes about the same time, but the migration can fail, it can lock something, and you should be able to retry it more often, or maybe kill it and retry it after some changes, etc. And this is a very safe approach. As I already said, if there's a bug in the new version of the application, you should be able to return to the old one. And the new state of the database is still compatible, so this is not a problem. And from my experience, you usually don't need any migration rollbacks because each step of the migration is backwards compatible, so basically nothing can go wrong. So we don't write migration rollbacks at all. We only go forward every time because there is no risk involved. Okay, so I will go through a list of things you can actually do to the database. So it's important to split the migration into multiple small steps. You should think about the deployment process during the development of the feature. So when you are writing the code for the feature, you should think about how to deploy it. So it usually means that you will split the work into multiple stages, and each stage will be deployed separately. So single feature request can usually result in multiple pull requests, multiple branches. And we are doing each step of the migration while thinking about the application, so that no step should break the application in production. So there's little probability that something will break. Okay, so when we are adding a new column, the first step is to add optional column. So when you add a knowable column, nothing can break in the application. And this is how you should do it, at least in MySQL, because the algorithm in place and lock on the last two lines enforce the database to make the migration without any locking. If it cannot be done, if there's some complication, then the MySQL will refuse to do the migration at all, and you will have to rewrite it somehow. This works for MySQL 5.6 and later, and it works with InnoDB. And this approach also always works, no matter how big the altered table is. It might take longer, but the table is never locked. And different database engines like Postgres supposedly don't have any problems while with locking for simple operations like this. Okay, so this is how the table looks like in the beginning, and we are adding a new column, and the table looks like this. In the next step, we will deploy new version of the application that will write to the column. So we go from this, and the new inserted rows suddenly have the column filled. So this probably means that the user started filling out this value probably during the registration process. And in the next step, we will run migration that fills in past data. This only applies if you plan the column to be required. If you want to keep it nullable, then you don't have to do this step. And the migration can be either an SQL query, or it can be a more complex PHP script. So in this case, we go from this to this. The migration probably guessed the gender of the users by their first name or something like this. It doesn't matter. It's a detail of this example. The migration needs to be done in batches in case of big tables, so that the table isn't locked, because you can't do big single update, but you should do probably an update for 1,000 rows advance and then repeat it in a for loop. Or you should write a PHP script that updates each row independently, separately. Okay, and once we have all the data, we can make the column required, non-nullable. And once we have that, we can deploy a new version of the application that reads the column, and we are finished. Okay, so there's a little bit of a paradox, because in order to have zero downtime migrations, we have to deploy more often. As you can see, this is a multi-step approach, and you will be deploying many times a day once you adopt this workflow. And important thing to realize is that when you are doing the first step, you don't even have to have the next ones ready. You can go continuously, and you don't have to prepare all the steps at once. But you can develop the first one, send it to code review, deploy it, and then you can start doing the next one. You don't have to do it at once. What's also great about this is that this workflow is non-blocking. So if you encounter a problem in one specific step on one feature from one developer, you can continue deploying work from another developer while waiting for the fix from the first one. And if the migration is taking many hours, you can still deploy different and unrelated changes to production. So typically, on a typical workday, you are in different stages of multiple migrations for different features at once, but it a bit, of course, depends on the size of your application and on the size of your team. Okay. The next thing you can do to the database is to remove a column. If you no longer need a column, then you should remove it. You shouldn't keep it in the database. And if you realize that you need to remove a column, the first step is to make it optional. And one more thing I forgot mentioning is that it shouldn't matter to you whether the affected table of the migration is big or small, or if it's heavy used or marginal. You should always do these steps, these backwards compatible steps, because even if it doesn't matter if it's some marginal thing in the administration or something like that, you will still learn how to do it and how to handle these situations. So you are exercising, you are training for the times where it really matters. Okay, so removing a column, make it nullable. Deploy application version that stops using it. So no select, no insert, no update doesn't mention the column anymore. And in the third step, you can drop the column. Okay, so next one is renaming a column. So you can't do that directly because you will break the application. You can't just switch the name of a column in the database, even if it's instant. So you have to combine the first and second scenario. First, you add the column with the new name, do all the steps required, so fill in the data. Once all the data are there, then you can switch using the column. And if you are on the new column, you can remove the old one. And changing type of a column is really similar, because you can combine also adding a column and removing old column. So you add the column with the new type, go through all the required steps, do the migration, and once you're ready, then you can remove the old column. The drawback of this is that you will end up with a column of a different name, even if you only wanted to change the type. But you can repeat the steps. You can again add the column with the original name, but the new type, and you can migrate back to the old column. And this is not necessary, because I'm usually happy with the new name of the column add. It's quite it's not necessary to do the second step to go back to the original name. Okay, creating a table is actually the easiest operation because there are no repercussions to the application. You can just do it. And this is also how you can extend the database schema if you're stuck with some older MySQL version and you can't perform non-locking alters on big tables and you are stuck. So, and I also actually recommend this instead of creating new columns that you intend to be always nullable, because separating nullable columns into separate tables leads to a better database design. So let's say we have again a table with users that combines anonymous and registered users. So there are users of different type in the same table. And we want to add columns that apply only to registered users. So one way we could go about it is to add nullable columns to the same table. So when we say that the users, the registered users must have an email and a city they live in, we do it like this. But that means that the database design is wrong, because the database design allows us to insert inconsistent rows. Because I said that the registered user must have an email and must have a city. But the third row and the fourth row doesn't comply with this requirement, because only some nullability combinations are valid. Either I have both values or non-values. So another approach to do this is to create a separate table that I will join, and this separate table has those columns required. So once a user is registered, he gets an inserted row into the user's registered table, and all the values in the registered table are required. So only some users from the first table will have a row in the second table. And there's no way to insert an invalid row, so I recommend this instead of nullable columns. It's much better. Okay, so that was about databases, but you can apply the same principles in other client-server relationships. So who uses Elasticsearch? Okay, many people. You might also struggle with downtimes, but you can use the same steps as you are using in a database to change the indexes on the fly and stay online all the time, so you don't have to do the downtime for Elasticsearch if you already learned how to do it in the database. So if you are adding a new key to an index, to documents, you can update the mapping with the new key in the first step. You can deploy version that writes to the new key, then you can reindex all the documents, and finally you can start using the new key. So it's really similar to the database. Something a little bit more complex is when you need to upgrade to a new version of something, for example, for Elasticsearch. So it usually means that there are some incompatibilities, and you would want to do it with a downtime, but that's very risky. So the safe approach how to do it continuously is to create a new server, a new node with a new Elasticsearch version, then update the application that it writes the new data to both nodes. Then you can write all past documents to a new node so that it has complete data. And between steps 3 and 4, you can actually test the new node. You can test the application, for example, in staging environment, that everything works, or you can A/B test it, for example, on half of your users. You can serve half your users from the old Elasticsearch and half of users from the new Elasticsearch. And once you are confident that everything works, you can redirect all traffic to the new node. And if everything is fine, you can stop the old node and delete it. So this is a very safe approach, and it's generally applicable to any client-server relationship like this. Another typical client-server relationships is when you have a single-page JavaScript application or you have some Ajax functionality. So when you have some new requirements from the clients, you can either all force them to upgrade, or you can also do it continuously without them even noticing or forcing them to reload. So when you are adding new key to read because you are adding some new capability to your client, you can first add the new client to the exported JSON or XML or whatever format you are using. Then you can start reading the key in the client for the users that, for new users that will come to your site. Then you can wait for all clients to update organically, so that all their caches expire or they restart their browsers or whatever. And if all new clients or the most of them uses the new version of the client, then you can stop publishing the old key if there was one. Okay. Another thing you are typically solving when doing some single page application is that you have some new data to write to the server. You want to require some new inputs to be filled from the user. So you can start accepting the new data, make them optional on the server, so the server already knows how to handle them. Then you can start sending the new data from the client. Again, wait for all the clients to upgrade organically, and finally you can make the new data required on the server. Okay, so now to deployments. Application on the server has a lot of reasons to hang during deployment. So I will tell you how to prevent these situations. But first, I would like to point out that deployments should be automatized. Deployment should not be a complicated process. It should require just a single step from the user. Just a click of a button or execution of some bash script or using some abstraction like makefile or think, but it should be automatized to maximum extent. So, and once you have some build script in makefile or think, you can also use it for builds on your continuous integration server to verify that each of your commit works and isn't broken. And also automation gives opportunity to add steps that will automatically happen every time and will improve stability of your deployed application. So how does actually your application looks like on the server? How does the directory structure work? So deployment should be atomic. So in a single moment, new request should be handled by the new version. And there shouldn't be any chance of an inconsistent state. So of course, most of us are probably versioning with Git. So you can involve Git in the process, but the website shouldn't be served from the working directory of the repository and updated with Git pull, because that gives you no opportunity to prepare the new version of your application for the incoming traffic. You just update the files and there it is. So you have no chance to prepare it. And also using FTP is completely broken and the update can take minutes and the code is inconsistent for a long time. So the correct way to do it looks usually something like this. So you have the production directory, which is actually assembling to the latest release. And with each deployment, you create a new folder and you can put some name, some timestamp to it, and prepare the application as much as you can for the incoming traffic before switching to assembling. So you can copy the application, you can prepare the config files, you can compile the DI container, you can compile template files, you can build CSS and JavaScript. And once you are sure that the new application is ready, you can switch the symlink. So that's how to do atomic deployment. There are some catches, there are some problems with that. So the problem number one is that by default, symlink paths are not resolved. So if there's a request handled in the middle of the deploy, it might load a different version of the file than you intended. Because imagine that you start handling a request, you are in the middle of execution of your application, and the deployment switches the symlink. So suddenly, a different version of a class is loaded. It might have different methods, it might accept different arguments, and your request that was handled, that was in the middle of handling, now is broken. So the solution to this is in passing the right parameter to PHP FPM, which will expand the symlink paths. So actually, this is how the final path that is required in the application looks like. So there is no longer any surprise what gets loaded and what doesn't. But with this approach, you have one problem. Because of different file paths, the op cache always caches the whole application again. So the more deployments you do, the faster the op cache is getting full. One solution to this is to reload PHP FPM from time to time, and this is mostly fine, and we did this for many years. We reloaded PHP FPM once a day, and it was ready for our next day deployments. But the more technical, a better solution is to have two PHP FPM pools. And this is really better if you can't afford any freeze up, if you have a lot of traffic. So with two PHP FPM pools, which is a really cool solution, you have one FPM pool that is the only pool that is serving production in that moment. And the other one is free, and it is available to be reloaded to free up the memory. And for the next deployment, you can switch to the FPM pool number 2. So the next time they switch, and now the first one becomes available for the reloading and for freeing up the memory. Another thing that is allows as a bonus, that once you have two PHP FPM pools, they can be used for warming up the op cache. So the one that isn't used in production currently, it can be reloaded, and then it can be warmed up with your PHP files so that there's no hang up during deployment. And calling the opcache compile file function has to be done through web request, because CLI and PHP FPM does not share any memory in the FPM pool. So you have to create some other virtual host that is only available to you to do the warming up of the opcache. So why do you even need to warm up the opcache? It's one of the main reasons why server can struggle with the new application version, because some file does not exist yet, and the first request asks for it. So the generation can happen for a long time. But if in the middle of the generation someone else comes by and asks for the same file, the final form doesn't exist yet. So again, the generating is performed again. So this duplicate effort by the server can really clog up its resources. And this applies not only to opcache, but also to generated code like templates, fetching data from database, etc. So this is also the reason why you can do warming up the opcache using this function built in PHP to prevent this situation and to have a really smooth experience when deploying your application. So I have a few more notes about caching. So the common mistake developers do is that they clear the cache with each deploy. I'm talking mainly about data caches like the result cache in Doctrine, etc. But you don't have to delete the cache with each deploy. It's not necessary, because if nothing related changes in your application, you don't have to clear the cache because it can be reused. And in case you need to refresh the cache if you want to clear it, again, similar to database migration and the deployment of an application, you can't synchronize those two things. You can't really cache the moment when the new version is deployed and then clear the cache, because you will definitely break some request for some user. So it's hard to cache the right moment. But you can rename the key. So if you rename a key, then the cache is cleared at the right moment, because when you deploy the new version, then you can then it happens when you want to happen, because when the new version is deployed, the cache with the new key is empty and the fresh data are loaded. Okay. To prevent concurrent data fetching, you can run a cron and push the new data to the cache. So you are not waiting for the cache to expire, because again you would face the concurrent data generation and fetching. But instead of clearing the cache, you can push the new data. So you can have a different code path in your application that will fetch the data and actually save it under the correct key. So then the front-end request will already have the data ready. But this is only really needed for pages under heavy load. So it's mostly fine to let it expire. This is only for the situations that really require it, for the most visited pages on your website. Okay. Another tip I have for you is that you should know about everything that happens in your application. So you should use something like papertrail or Sentry. I hope that everyone already monitors errors in their application. But the thing that people usually forget about is that it's not sufficient to log errors only in your PHP application, because something like HTTP 502 bad gateway or 504 gateway timeout can happen, and the request does not even reach PHP FPM and does not reach your application. So if you are not logging your 502s and 504s, you don't know about a lot of possible errors your users can see. So this is also very common during deployments because of OP cache related issues and higher load that comes from the deployment. So you should also set up logging of these situations in your web server. Okay? So that's all from me. You don't have to follow all of the advice at once. You can start with some basic points, and if the app and the users demand it, you can improve your setup. Okay? And you can contact me on Twitter or by email and let me know if you need some help with this area. Okay? Thank you very much.